Hello everyone, I hope you're having an amazing day. We got newcomer over here. Hey newcomer, how's it doing? We got him over here doing my backup on my video today. So a couple of things we're going to be talking about. Everything we've been doing so far the last lesson has been in degrees, degrees and radians. We've been dealing with calculators, so we're going to do more of this today. To start off with, go ahead and get your calculators out, turn them on, make sure that they're in degree mode to begin with, and then we will go from there. Okay, so solving trig equations using a calculator. First and foremost, just like you saw me just do, check the mode on the calculator. Your mode has to be in the correct mode. So if you're dealing with degrees, like number 1 is, then you're in degrees. You're solving for 0 to 360 degrees. Number 2 says isolate the trig function, which means get it by itself. So you get the trig function alone, and then you ignore the sign of the answer and you use the inverse function to solve for the reference angle alpha. Blah, blah, blah. That's where it gets interesting because this is what we haven't done so far. If you start with cosecant, secant, or cotangent, you have to get it to your sine, cosine, or tangent. That's what 3 says. 5, place alpha in the correct quadrants, blah, 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 blah. Okay, so there's really one step in here that we haven't done before, and it's going to be number 4. Here's how this is going to work. Sine of theta is negative 0.82. That's fantastic, but that is not on our unit circle. So there's no possible way for us to come up with that unless we do something a little bit creative. So first off, we're going to come up with the reference angle here, or with the theta, in other words. So when I set this thing up, theta is going to be the inverse sine. It's the inverse sine, which is sine to the negative 1. And if you look on your calculator, there's actually a button right above sine. Will it focus? Will it focus? No, it won't. There it is. Right above, there he goes, right above sine right here. There's a little sine to the negative 1 thing, because we're ghetto like that. That's how we're going to do our zoom. And there's a little sine to the negative 1 thing of 0.82. What this does is it allows you, 0.82, what it does is it allows you to figure out what the reference angle for this actually is. Notice I am ignoring the fact that it's negative. Kind of like on yesterday's lesson, we ignore the fact that it's negative and we come up with alpha. Right? That was part number 4. Ignore the sign of the answer and use the inverse function to solve for the reference angle alpha. So what I'm going to do is grab my calculator and I'm actually going to type second sine of 0.82. Now I've already checked that I'm in degrees. Hit enter and you should get 55.084. Andrew, is that what you got?
Yep.
Fantastic. So we get 55, and are we rounding to the nearest degree? Yes, we are. We got 55 degrees, rounding to the nearest degree. So I came up with alpha, and now I've got to place it in the correct quadrant. So it says place alpha in the correct quadrant. Well, think about this. Where does sine give you a negative value? Sine is negative wherever your y's are negative, which means it's going to be, oops, down here. That means that this angle is 55 and this angle is 55. So it's a little bit different than yesterday. If you remember from yesterday's lesson, we took the reference angle directly off our unit circle. Well, what this right here does is allow us to get away from the unit circle, because unit circle is fantastic, but it's so limited on what you can do. You can only use 30, 45, or 60. Well, now we can use anything we want. So I got a reference angle of 55 degrees. So I'll take theta is 180 plus 55. 180 degrees plus 55 degrees since you're in quadrant 3. And that's 235 degrees. And then you take the fourth quadrant, which is 360. Minus 55 degrees is 305 degrees. 305. That is a technical number if you are from the south. 305. That's how we do in the South. You just drop the last letter off of anything that you want to say. So instead of saying I guess, you say I give.
And consonants.
And consonants. You drop consonants too. All right, let's go to number 2. 5 cotangent of theta equals 12. So if I went back up to my steps here, step number 2, if you look at the top, says to isolate your trig function. It says to isolate your trig function. So we're going to start off here getting rid of our 5 that is in front of our trig function. Divide by 5. And we get cotangent of theta is 12 over 5. Now this goes to step number 3, which says convert reciprocals into sine, cosine, or tangent. So instead of sine, cosine, and tangent, I have a cotangent here, so I'm going to change it. I'm going to change cotangent of theta into tangent of theta is 5 over 12, because I know that cotangent and tangent are reciprocals, right? Since cotangent and tangent are reciprocals, I can just take and flip 12 over 5, make it 5 over 12. There's your tangent. So set it up here. Theta is going to be the inverse tangent of 5/12. Now what that inverse tangent did is it flipped it across the equal sign. It's kind of like if you had an equation that was like x plus 2 equals 5. You would do the opposite of this, which is subtract 2, and then move it over here, right? Well, this inverse tangent does that to tangent, and it leaves us with alpha. So coming up with what we actually have here, we have the inverse tangent of 5/12. I'm going to grab my calculator. Second tangent, 5 divided by 12. And you get 22.6. Round up, you get 23 degrees if we're rounding to the nearest degree. So that's 23 degrees. So you've got 23 degrees as your reference angle. Let's talk tangents. I've got cotangent and tangent, both of these here are both positive numbers. So where is tangent positive? Andrew, where's tangent positive?
First and third quadrant.
First and third quadrant. See, this guy's paying attention and everything. Here comes the air conditioner. Woo! First and third quadrant, 23 degrees here. 23 degrees here. So you've got theta is, for the first quadrant, this one's pretty obvious, it's just 23 degrees. For the third quadrant, you got 180 plus 23, because this is your entire angle. Boom! So it's 180 plus 23, all degrees here, which is 203 degrees. So we've got a couple of things going on here. All right. Now, the reason why I took the reciprocal back here is plain and simple. My calculator doesn't have a cotangent button. Now you could argue and say, "But Mr. Ballard, there's an option in the menu to cotangent." No, cotangent is not a button. I don't want to use it. I want a button. Now some actually do have buttons, but not this one. Flip the page. Let's go on to the back here. So 3 cosine of theta plus 9 over 7. I want to get cosine of theta by itself. If this was 3x plus 9 equals 7, think about what your first step would be. Well, first, you'd subtract your 9, wouldn't you? So I'm going to do that here. Subtract my 9, a little bit of algebra. 3 cosine theta equals negative 2. Then you're going to divide by 3, and cosine of theta equal negative 2/3. Right? Cosine of theta is negative 2/3. Solve for theta, then do the inverse to come up with alpha. So alpha is going to be the inverse cosine of 2/3. Please remember that you are forgetting the fact that it's negative for right now, just like we always have, because it's a reference angle. Reference angles are always positive. So forget the fact that it's negative. Come to this guy, punch in numbers, and you get 48 degrees. And again, you look at cosine being a negative value. Where is cosine negative? Cosine is negative here and here. So it's 48 degrees, 48 degrees. So come up with what your thetas are. Theta is 180 minus 48 to go to the second quadrant. So you got, what, 132? Yep. And then 180 plus 48 to go to the third quadrant. So 228. There your answers be. Now, sometimes you may have more than just two answers to these things. And I'm not just talking about going from radians to degrees. But there are occasions where you may have, just simply put, more than one set of answers. For example, number 4. Now, a little note on the notation here. Cosine squared means cosine of theta squared. Cosine of theta squared means cosine of theta squared. There's a big difference between these two things. Where that square is at is going to make a world of difference. So solve it like it's an algebra problem. If this was 4x squared minus 3, first you'd add 3. And you'd have 4 cosine squared theta equals 3. Divide by 4, just like it's an algebra problem. So cosine of theta is 3/4. And here's where the interesting part comes in, because I'm going to square root both of these things. Square root these. And you get the cosine of theta is equal to, now when I took the square root of something, kind of like when you take the square root of 4, it's not just 2, but it's positive and negative 2. Same thing goes here. This is positive negative square root of 3/4. And you can actually break up positive and negative the square root of 3 over the square root of 4, which is plus minus the square root of 3 over 2. So just to write this in one fashion here, I've got cosine of theta is equal to positive and negative square root of 3 over 2. Okay, so let's say you wanted to do this with your calculator here. To do that with a calculator, you'd enter it the same way we did it before. But let's say, just for kicks and giggles, that you do not use a calculator. Gasp and such. Where is cosine the square root of 3 over 2? I don't even have a unit circle anywhere. But where is oh yeah, dude. Bam! Where's your cosine the square root of 3 over 2? How about 30 degrees? How about an alpha equals 30 degrees? Now the big question, where oh where is cosine positive? Positive here, positive here. But where's cosine negative? How about here and here? So I'm telling you that this is telling me I've got 4 answers. This guy, this guy, this guy, and this guy. 4 dadgum answers. 30 degrees. Quadrant 2, 180 minus 30 is 150. Quadrant 3, 180 plus 30 is 210. And 360 minus 30, 330. So if you ever have to take the square root, please keep in mind that a square root is not just a number, but it has to be a